Hopefully you've had a chance to listen to the video that I had before this one, where they actually talked about the far side versus the near side of the moon. And over here, this figure is actually kind of talking you through how that works. Here we have the Earth in the center, and this gal is actually acting as the moon. So notice as she goes around an orbit, this gal is orbiting the Earth. She is also spinning around. So here she has spun 1/4 around, here another quarter, here another quarter, and then she comes back around full circle. So as she goes around, as she orbits, she needs to spin on her axis. The important thing here then is that notice that we always see the front side of her, we being the folks on Earth. Okay, so that's actually called synchronous rotation. And I guess the other thing I wanted to mention is if I were gonna ask you, most people would say that this is the one that we see. This is the moon that we're used to seeing. Actually, this is what we call the near side. And this over here, this pockmarked one, is the far side. So the back side got more hit than the front side. And then another thing I want to mention about the moon, I want to mention so many different things, but the moon is actually moving away from us, slowly but surely. It's slowly moving away from us, and it actually has to do with I want to say the conservation of angular momentum, but it's kind of a torque thing. So we know that the moon is moving away from us because we can shine a laser on the moon. You're like, well, what will that do? Well, while one of the Apollo missions was up there, they put a mirror up on the moon. So this is a mirror on the moon. And so this light hits that mirror, and then that light returns. And we've talked about how light, you can actually track how fast, well, you can track how fast it moves, but you can track how long it takes to get from point A to point B and then back to point A again. So it's taking longer and longer, telling us that the moon is moving away from us.